let the initial velocity of object be 10 meter per second, or select, yeah, 10 meter per second. Acceleration 2 meter per second square. At t equal to 10 seconds, or select 5 seconds. T equal to 4 seconds. We'll calculate what is the distance covered. So this is about the data. I'll write it. Yeah. Initial velocity 2. So at 2 instants of time, we'll take this one. T equal to 5 seconds, T equal to 4 seconds. I'm just going to describe everything. So we do have this a road. I'll come to this. Okay, let's do one thing. At t equals 0, there's a time in seconds, velocity of the object, and the position of the object. So what is the formula we are going to use? S equal to ut plus at square. I'm just trying to explain what do you mean by distance covered in n second. So the formula now it will end up S equal to what is value of u 10t plus a is 2 by 2 t square. So 10t plus t square. Agreed? The acceleration is 2, no? 2 divided by 2 will be 1. So t square. Okay, put t equal to 0. What is the initial velocity? What is the velocity of the object? 10. What is the position of object? Initially, let it be at origin. At t equals 0, scooter is at origin. In the end, I'll bring the diagrams. Huh? Now let me first get the data. Now at t equal to 1 second, what is the velocity of particle will be? What is the formula? V equal to u plus at. U is how much? 10 to t. Put t equal to 1, it will become 12 meter per second. What is the position of particle? Put t equal to 1. So this will be S1 is equal to 10 into 1 plus 1 square. So I think this will be 11 meters. Put t equal to 2. So this will be 10 plus 14 it will become. So what about the next position? S2 is equal to 10 into 2 plus 24 meter. It will be at 24 meter. 3, it will be 16. .36 meter. 4, it will be 4 will be u plus 18. Okay, S4 will be 10 into 4 plus, oh, some data went wrong, no? 2 into 10 into 2, this will be t square, 2 square. Okay, there's no problem with this. This will be 10 into 3, 3 square. 30 plus 9, 39. Now I'm making changes. 10 into 4, 4 square. This equation we should apply. I think some of you are getting confusion with this, and I'll move it separately. Based on this, here in this equation, substitute value of t and tablet. So this will become 40 plus 16, 56 meter. S5 will be 10 into 5 plus 5 square, 50 plus 25, 75 meter. Oh, okay, I have data. So 56 meter. This will be 2 into 5. This will be 20. 75 meter. What actually, what is the meaning of all this? Because I just wanted to give the idea of the distance covered in nth second. The distance covered in nth second, what meant that has to be clearly explained. So therefore, I'm gathering the data at various instants of time. It will be here. Okay, let's take help of the diagram. Okay, now I think now you clearly understand what actually I wanted to explain you. This point is what? S equal to 0. 75 meter is there, no? Okay, we'll divide this interval into 20, 20, 40, 60. Okay, 20, 40, 60. This is 80. At various instants of time, we'll locate where the scooter will be. And proportion will indicate the time also. T equal to 0, T equal to 1 second. So it will be 1 second, it will be at 11 meters. One second. 24 meter, 20, this will be 30, 24. It will be here. This will be 2 seconds. It will be at a distance of 36 meters. I think S3 will be 39. Sorry, some data. 39 it will be here. Next 56, so it will be here. 75, so it will be here. No. Okay, where is our scooter? I would have just took particle. Many students find very difficult. The moment I say particles are, we are not understanding. Okay, scooter is here. Then he will be here. Last one. Wait. Yeah. Now take help of this one. Okay, now you see that first 1 second. How much of distance he will move? He will move 11 meters. Next, how much of distance he will move? 24. There's a distance covered. You see the distance covered is keep on increasing. The length of arrow is keep on increasing. I didn't draw up to the scale. Okay, but still you can see this. Okay, we are bothered about. So first it will cover how much? 11 meters. In 1 second. Next second, it will cover 13 meters. 24 minus 11, you see. 39 minus 24 will be 15 meters. 56 minus 39 will be 17 meters. Next, 75 minus 56 will be 19 meters. Able to understand? In the first 1 second, it will cover 11 meters. Next 1 second, 13 meters. Next 1 second, 50 meters. The distance covered in equal intervals of time is keep on increasing. What is the duration of time? 1 second, you can see. Other side, let me indicate the duration of times. 1 second, 1 second, 1 second, 1 second. Okay, what do you mean by the distance covered in nth second? Because our main purpose was to study the distance covered in nth second. For 4 seconds, how much of distance it will move? For 4 seconds, what the distance it will move? For 4 seconds, what is the distance it will move? S4 will write it. For 5 seconds, this will be S5. So how to, what is S4? Distance covered for 4 seconds, distance covered for 5 seconds. No, I'll ask you distance covered in 5th second. What do you mean 5th second? You have to call like this. Say there's what here. This call like a 1st second, 2nd second, 3rd second. I'll remove this 20. Some of you are getting confusion, sir. Like a okay, no. I think things are very clear. Okay, no. Distance covered in 1st second, how much? 11 meter. Distance covered in 2nd second, 13 meter. Distance covered in 3rd second, 50 meter. Distance covered in next year, like a year center. Distance covered in next second, 17. So this is a distance covered in nth second or in the 5th second. Instead of writing this, you can call this the 1st second, 2nd second, 3rd second, 4th second, 5th second. Okay, let's do one thing. Distance covered in 5th second I want. So what you should do, distance covered for 5 seconds minus distance covered for 4 seconds. I think that was the formula. So let me rewrite. Distance covered in 5th second. How much it is? We know it is 19 meter. This is also equal to what? Distance covered in 5th second. You can also write it as distance covered in 5 seconds minus the difference, the distance covered in 4 seconds. That will become distance covered in 5th second. There's an interpretation. So let's see that. S5, S5th, I'll write it. Distance covered in 5th second. How much distance covered for 4 seconds we have here? 56. Distance covered in 5 seconds, 75. Same thing, no? So instead of doing so much, we have directly a formula. What is the formula? Sn equal to un plus this one. U is how much? 10. Acceleration 2. So what is the formula? U plus U plus A into n minus 1 by 2. Let's see what will get it. 10 plus 2. So this will be 5 to ja 10, 9 by 2, 19 meter. So there's the difference between distance covered for 5th second, distance covered in 5 seconds. So this should be S5 minus S4. I'll write one more step. 75 minus 56. So finally, how much? 19 meter. Now tell me, like if I ask you such a question, you have to really work out so much, no? Here. So instead, this formula will help you a lot. Distance covered in 5th second, directly substitute that formula. Or else what you should do, you should find out distance covered for 5 seconds, distance covered for 4 seconds. The difference of that will be the distance covered in 5th second. So distance covered for 5 seconds, distance covered for 5th second. It's different. So this is the 1st second it is called as. I will write this, may not be, this is called like a 1st second. second second. This called like a third second. Fourth second. This called like a fifth second. Agreed here? So like this, what happened? We have this particular formula. Distance square for nth second is also a very good formula, which will help us a lot. Now, what is the type of motion? It's an accelerated motion. How the acceleration is directed? The acceleration is directed. Let me indicate that acceleration because that is very important. The speed of the body is continuously increasing, no? So it's said to be describing the accelerated motion. Okay, everyone, I think understood the distance code in nth second meaning means that formula is given in book. Okay, it is going to help us a lot. Okay, let's further, we'll discuss the